Hey everybody, welcome to our third section of Chapter 1, Introduction to Psychology. We've covered quite a bit of ground so far. We started out with the definition of psychology, the scientific study of behavior and mental processes. Then we looked at goals of psychology to describe, explain, predict, and influence. Old school, how it all got started with structuralism, and then functionalism, how that rose here in America. And in the previous section, starting to look at descriptive research methods with naturalistic observation, the case study, survey method. And the final descriptive research method to look at here is the correlational method. The correlational method seeks to determine is there a relationship between two variables so that one variable predicts another variable. Not that it causes it, that can only be done in the experiment, and that comes in our last section. But only, do they go together like bacon and eggs? So that where there's one, there's usually another. Here's an example to look at. Does the color of your eyes predict your grades? Well, of course not. And you would be totally shocked if I told you researchers just found a relationship with that. You know that is major bogus, don't you? But suppose I ask you, you think there's a relationship between how much stress you've been under lately and your health? I think you would say there is something to that based on my past experiences. We call this a significant correlation because in most people, as stress increases, health problems, visits to the doctor, taking medicines, all that increases as well. And here's how it works. I could take two measures on each person in class, one on your report of how much stress you've been under lately, and the other on your report of medical problems. We could do that easily enough. Now look at this scattergram, and I'm going to use my cursor to illustrate some things. This horizontal, here we go, this horizontal axis we call X will represent stress ranging from mild to, here we go, increasing mild to moderate to severe on the right end. And our vertical axis will represent health problems, starting with very none or mild at the bottom, moderate, and then increasing as we go further north there. I could take two measurements on each person in our class, how much stress you've been under and your health problems. And here's what it would look like. One person would report maybe very few health problems and very little stress. And so we go up like this. Another student reports that they have average stress going this way here, and average medical problems, we would go up, and their point would fall somewhere in there. And then another student might report that they've experienced severe stress and severe medical problems, so we would plot their point up there. After we've plotted 2 points of data on each person in class, we could graph these, and it would probably fall on an imaginary line, that goes from left to right in the upper right-hand corner like that. This is called a positive correlation. It's called a positive correlation because as one variable increases stress, the other variable increases medical problems. It's called positive because both increase mathematically with one another. But there's no value judgment here about a positive correlation representing something good or desirable. Now, here's another example. Do you suppose there's a relationship between hours spent on social media a week and your grades? I think many of you would now say, yeah, there's probably something to that. I know based on my own experience. Well, as in the previous example, I could take two measurements on each person in class, the number of hours you spend on social media, and your current GPA. And in this instance, the x-axis represents GPA with the left side being a very poor GPA, and as we move further along out to the right here, Let me find my cursor. There we go. As we move further out to the right, the GPA increases. The x-axis represents hours spent on social media. And with the bottom, very little to none per week. And then as we go higher, very high levels of social media per week. Plotting the data for each student in our class would probably result in a pattern moving from the upper left-hand corner down to the lower right-hand corner. In other words, people who spend the most hours a week on social media, generally speaking, have lower grades than, they're up here, than people who spend the least hours on Facebook, YouTube, and Twitter, and they generally have higher grades over here. This is called a negative correlation because as one variable increases, social media, another variable decreases along with it, grade standing. And we call it negative, again, because as one variable increases in mathematical terms, another variable decreases in mathematical terms. We don't call it a negative correlation because we're being judgmental or negative about social media. Now, you might be saying, hey, I'm an exception here. I've been under a tremendous amount of stress in the past 6 months and my health is just fine. Or you might say, hey, I know people who don't even own a smartphone and they make poor grades. I make better grades than they do and I spend a lot of time on social media. Well, that's absolutely true. There are always exceptions in a correlational study. But in a significant correlation, there is a general trend or tendency, and that's what we're interested in. The strength of any correlation can be represented by a number ranging from positive 1.0 to negative 1.0 called the correlational coefficient. And we derive this from a mathematical formula, which looks like this, but is way beyond the scope of our class, so don't worry about the formula. I just want to show you that when you take a stats course, you'll learn how to use this. A 1.0 correlation is a perfect relationship with no exceptions. Would you ever expect to find that when we're dealing with human behavior? No, you wouldn't, because we are far too complex and complicated, and we have a streak of unpredictability, don't we? There are always exceptions. So when we obtain a correlational coefficient plus or minus 0.5 or higher, that is often statistically significant, and it's exciting to find that. Again, it's the distance from zero which indicates the strength of a correlational coefficient, and not whether it's positive or negative. If you're a researcher and you tell me, hey, we got a significant correlational coefficient in our correlational method, I don't ask you, oh, is it positive or negative? I want to know what the number is. That's the most important thing. We can talk about positive or minus later on. The value of the correlational method is that it allows us to make predictions, which is the third goal of psychology: describe, explain, predict, right? If I know that you've been under significant stress recently, I can bet that your health has not been the greatest. Now, I'll occasionally lose that from time to time, won't I? There's always exceptions. But I will come out ahead in the long run, believe me. And if I know that you don't spend much time watching random YouTube videos, except for these, I can predict that you have good grades. Again, I'm going to lose that bet from time to time because the correlational coefficient is less than negative 1.0. But in the long run, I'm going to make enough money to go back to Carlsbad and have some of that pizza and Coke that I like so much. While the correlational method allows us to make predictions, it does not allow us to make a cause and effect statement. I've said that before. I cannot overemphasize that point. This is one of the most difficult concepts to grasp in all of psychology, and I know I struggled with it when I was an intro student myself, so don't feel like the Lone Ranger here. We'll keep going over it and over it. We know that stress can reduce the efficiency of the immunological system. We know this now. to fight off disease, and it makes you vulnerable to opportunistic infections. But can we say that stress caused these people can we say that it caused people to get sick in every instance of our correlational data earlier? We can't say that. Have you ever gone through surgery and a long rehab program afterwards? Can medical problems cause stress, at least to some extent in some people? Of course it can. Have you ever experienced poverty, homelessness? This is a variable we didn't even include in our correlational design. Can that cause both stress and medical problems, at least to some extent in some people? Well, that's true too. My point is this: as tempting as it is to look at a significant correlation and jump to a conclusion and say, oh, I know what's going on here, A caused B. We cannot do that. We can never do that. All we can do is say A may have caused B, B may have caused A, or even a third variable, C, caused both B and A. We cannot make a cause and effect statement. Well, that's the correlational method. It's the last of the descriptive research tools, and all of these methods that we've studied so far are useful for working with the first three goals of psychology. And what are those again? Describe, explain, and predict. But none of them, I repeat, none of them allows us to make a cause and effect statement and address the fourth goal of psychology, which is influence. Only in the experiment can we address cause and effect. And that's coming up in our last section of Chapter 1. See you there. Bye-bye.